Okay, here we go with section 5.3, where we're going to find the equations of the parabolas that we are making. Okay, so this is basically quadratic functions. They take the shape of parabolas. What we're going to be using is the standard form of that equation, y equals a bracket x minus h whole squared plus k. Hopefully you can remember that that vertex that we've been looking at, right? The vertex is actually at h and k. So if you have the vertex, you can plug it in here. If you have a point, you can also plug it in because points are x and y's. And what we're going to often try to find is that a value, which gives us the shape of those graphs, okay? So the shape, the a, can be either a positive or a negative. Negative means that it opens down, right? And we looked yesterday or the day before or whatever, the previous section, at how the a changes the shape, right? If it's 2, it gets skinnier up like this, right? And if it's a half, it gets fatter. My hands don't really show you very well. But hopefully we'll get, you've got that somewhat dialed already. Okay, so what we're looking is to make an equation in this form here, given some information. And the first thing we're going to look at is a graph. Okay, so here we've got a graph. Let me slide it up here so that you can see. We'll do both of these. Okay, so if we look at this graph here, this first one, okay, you can see that the vertex is up at -2 and 5. Okay, so if we start plugging stuff in here, we're going to go x, sorry, it's not -2, it's +2. So x minus 2 all squared plus 5. Notice that the only thing I don't have is the a value, right? Because your equation always needs to have an x and a y in it. So what do we do now? Well, we try to find the a. You can get that in a couple different ways. Look at the graph. If I go over 1, I go down 2. Over 1, down 2. That means that my a is negative, and I'm going to guess that it's -2. Okay, so how can we find that out for sure? Well, look at these other points that I have. Okay, these are points that are on the parabola. So I'm just going to pick one. Let's pick this one right here. That point right there is 1 and 3. That's essentially an x and a y, just like your vertex is the h and the k. Okay, so let's plug those numbers in there now. My y is 3, so 3 is equal to a bracket. My x is 1, minus 2 all squared plus 5. Bring the 5 over, becomes a minus 5, so it's minus 2. 1 minus 2 is -1 squared is 1, so 1a. So a is equal to -2. And that absolutely is what we just guessed. So my final equation would be -2x, right? Minus 2 all squared plus 5. Okay, that is the final form. Remembering that you need to have an x and a y in here. Otherwise, it doesn't describe the function. We can't find other points. Take a sec, give this one a shot. Okay, and I'll finish it off in a second here. First of all, I identify the vertex as -2 and -1, so I plug that in here. A bracket x minus a minus would be +2, all squared, -1. Now, if I look at the graph, I can see that it's over 1, up 1. Makes me think that the a value might be 1. Well, let's just use another point here and try to figure it out. Any point will do, okay? I just pick any point. It doesn't really matter. This point here is 0 and 3. So what we'll do is we'll use a point 0 and 3. Remember, that's your xy. The vertex is your hk. Let's plug the y in here. 3, a bracket, x is 0, so it just becomes 2 squared minus 1. The minus 1 comes over here. I get 4 is equal to 4a. That means a is 1, like we thought. And now the final form is 1 bracket a, or a bracket x plus 2 all squared minus 1. And this describes that function. It's not always going to be easy to identify the a from the graph. It might go up like 1.5 or a third or a quarter. So the other option, like we're showing you here, is to do the algebra. Okay, so this is getting an equation given the graph. So let's look at another situation. We might be given, for example, we might be given a vertex of 4 and 8, and you might be given an x-intercept of 6. Now, what that means is, well, we got kind of the same information, right? the best thing to do here, guys, is just to plot it up. Okay, so let's have a look here at the graph. So if I go over 4, 1, 2, 3, 4, and up 8, 1, 2, 3, 4, 5, 6, 7, 8. Here is my vertex, right? X-intercept of 6. So 1, 2, 3, 4, 5, 6. There's an x-intercept of 6. Now you can see that it's symmetrical here a little bit, right? So over 2, back 2, there we go. Not so easy to see the a value here. So we're going to have to do a little bit of different math, okay? So let's plug some numbers in here. This is my h and k. The x-intercept is 6, but that's actually a point, right? 6, 0. That's your x and y. So let's plug the vertex in first. Y is equal to a bracket x minus 4 all squared plus 8. Now let's use the point. The y value is 0. X is 6. This is going to give me a negative 8 on this side is equal to 6 minus 4 is 2. 2 squared is 4a. If you divide both sides by 4, you get a is equal to negative 2. And what you can do from that point is just kind of see if it makes sense. Let's finish it off first. Minus 2 bracket x minus 4 all squared plus 8. This would be my final equation. And if we look at the graph here, over 1, down 2, because that's my a value, right? Over 2, I used to go down 4, now I go down 8. Bingo, I end up on the points that I asked, or that I plotted to begin with. So hopefully you can see that it's very similar to graphing them when you have the graph, because you're given the vertex and you're given a point, okay? Now there are other situations where you will not be given the vertex, you will not be given the graph. You're going to need to find out the equation just given 3 random points. So let's look at that situation. If I have 3 and negative 4, and then another point at negative 3 and 2, and another point at 1 and 2. Very difficult to see what's going on here unless you actually graph it, okay? So positive 3 and negative 4. And then we'll look at negative 3 and positive 2, 1 and positive 2. Well, it's looking like it's opening down. See how these are on the same level? So the symmetry has to lie right down the middle here, okay? So you can see that x equals negative 1 is my axis of symmetry, okay? So my vertex then is going to be negative 1 and k, and I don't know what k is, all right? But we can start making equations here. Let's plug them in. So y is equal to a bracket x plus 1 all squared plus k. Now I've got a lot of variables in here, but I'm starting to fill it in. Let's use one of these points here, okay? Let's use one of these points. So what we're going to do, let's use the easiest one, 1, 2. So that's an xy. Let's plug it in here. So 2 is equal to a, x is 1 plus 1 all squared plus k. What this gives me is 2 is equal to, this becomes 2 squared, which is 4, so 4a plus k. And I got k is equal to 2 minus 4a. So now my new vertex, I can look at it, it's going to be negative 1 and 2 minus 4a. Okay, so all of a sudden it's getting a little more complicated, but we can still do it, right? My new equation now will be y is equal to a bracket x plus 1 all squared, and my k value is 2 minus 4a. So you can see that I've got 2 a's now, but I've got an x and a y still. We use this point already. We use this point to help me find this k value, so we need to use a different point now. You can use this one or this one, it doesn't really matter. Let's pick this one here. So if I use now negative 3 and 2, I can start plugging things in here. 2 is my y, a, minus 3 plus 1 all squared, plus 2 minus 4a. Well, we're getting a little bit closer here, okay? We can bring this 2 over to this side. It becomes negative 2, so I have 0 is equal to, now this becomes minus 3 plus 1 is negative 2, squared is 4a minus 4a. Oh, look, I end up with 0 equals 0. So what happened here is that I might have used a bad point. So this point maybe didn't work. Obviously 0 is 0. So what we're going to actually have to do, I'm going to erase all this, and I'm going to suggest using the other point, okay, because that one didn't work for me. So let's use the other point. Let's use 3 and negative 4. Okay, so negative 4 is my y. A bracket 3 plus 1 all squared plus 2 minus 4a. Let's bring this 2 over here. It's going to be negative 2, so I got negative 6 is equal to, this becomes 16a minus 4a. I get negative 6 is equal to 12a. A is equal to negative 1/2. So I kind of went down the wrong path there. I figured out that that didn't make sense. So I've got 2 other points to choose from. I just picked a different one. And now the final form of my equation will be negative 1/2 is my a value. It's going to be x plus 1 all squared. What's my k though, right? What's the k? Well, let's look up here. I have 2 minus 4a being my k. So 2 minus 4 times negative 1/2 is my k. This becomes 2 plus 2 is my k. 4 is my k. So my vertex now is, I've got my vertex, it's negative 1 and 4. So we jump back to the graph now. Negative 1 and 4 is my, up here, 4 is my vertex. And I have my final equation right here. Does that make sense, right? Negative 1 plus 4, over 1 down 1/2, over 2, it used to be down 4, now it's down 2. Bingo. So I ended up right on the point that I wanted. The graph and the algebra, they kind of jive. This one is a little trickier, okay, these types of questions. But all you have to do is start plugging them into the equations that you know, substituting some numbers in, using the graph to help you identify certain points and find the axis of symmetry, and hopefully you will have some success. All right. See you next time.